Hello and welcome to this talk about designing function families and bundles with Java behaviors, parameterizations, and lambdas. A few words about me. I'm Alain Lompo. I'm a software developer at Senacor in Germany. We have been building e-banking solutions using Java, GE, and Spring Boot in the backend, and Angular and React on the front end. I am available at my Twitter's account. And here's the plan of this presentation. I'll first tell you about my motivation for doing this talk. Then we'll address a certain issue and we'll see how we can solve it using functional programming with Java. And then I will discuss about behaviors parameterization and see how we can design parameterized families of functions to apply behaviors parameterization on them. And then we will see some applications and demonstrations, and we'll finally wrap up with what we have seen during the talk. So let's start with the motivation. What led me to present this talk? In a few words, it's about the fact that user requirements are sinking sand. What do I mean by that? Is simply that user requirements always change. Of course, at first, they always seem to be good, and we are always excited about implementing the new functionalities. But over time, it happens generally that they change during the course of implementation, and sometimes even after the implementation. We have a tendency sometimes to blame it on the methodology that we are using to make the development. But actually, the methodology doesn't really matter. It doesn't matter what methodology we are using. We'll still have to face these user requirement change for a variety of reasons. But of course, depending on which methodology we are using, it can happen that we notice this necessity for changes earlier or later. For example, with agile methods, we generally find about the necessity to change them earlier. Well, this has a direct impact, of course, on the cost of software application lifecycle management, especially the fact that the maintenance costs are generally more than the initial software implementation. With the help of behaviors parameterization, with functional programming in Java, we can help reduce these costs significantly. And of course, we want our developers to keep always happy. And things that make generally developers happy, and this is of course opinionated, this is my opinion about it, is the fact that they can successfully implement the tasks they are assigned and be able to put them in a ready for production status. And the other fact will be that they should be able to soon enough detect that a task is not clearly specified enough to be implemented. In that situation, they will move the task to a status of requires more clarification, or that the task can be completely blocked. Of course, in both cases, the developer can move forward with his activities and go about taking new exciting tasks and live happily ever after. The other case is when the requirements keep changing and then the developers team goes in a merry-go-round trip with the business stakeholders and they keep implementing and new changes come for the same task and the task takes forever to close. That makes them very sad. Now we'll see how through functional programming we can address the issue in order to solve it. Some of the main benefits of functional programming are the following. First, it helps us to finish our task on time and to meet deadline. The reason is functional programming is very expressive, it's short, it's concise, it takes less code to write the same functionalities as the classic approach. The other reason is also that with functional programming, we can write correct code in which we avoid mutability, and we avoid also state handling issues. We avoid null values and handling null pointer exception cases. We avoid using external iteration. And generally in functional programming, we try to express an intent. We try to express the what instead of trying to express the how. More benefit about functional programming is the fact that it's a better way to handle complexity, and at the same time still write simpler code. It also helps us. It leads also to the possibility of using more advanced algorithms and provide better functionality. Another aspect is functional programming is efficient and it allows us to write scalable code that can be easily parallelized. We can use practically the same code expression, but tell the compiler that we want to execute the code in parallel. It's also providing us better abstraction for writing reactive code and asynchronous code. Sometimes it's a good thing to try to compare a little bit functional programming with object-oriented programming. Java is, of course, fundamentally and from the beginning object-oriented, but since Java 8, functional programming features have been included in the language. So we know that in Java, everything is object. Everything exists as objects. But sometimes we have cases where we simply need to have the possibility to use a functionality without really needing a whole class or a whole object. But the basic features of Java did not offer that until the introduction of functional programming in Java 8. Just for illustration about that, let's consider, for example, this class where we are designing a car class. We have some fields of the car, some attributes, and we have also some methods here, or we can also call them some behaviors. This makes sense in that case because, for example, when I want to define a start method, that start method will not have any meaning outside of the context of the car. So this is a behavior that is related to the object of a car. And if I want to use it, I need to instantiate that class as an object and call the method on it. And we can see, for example, that we have state handling, we have mutability. This state attribute is changing by every behavior. Every behavior will have to impact that attribute and mutate the state of the object. And of course, we could make some simple tests to see that it's working as expected. For example, that when I call the start method, it will start and it will mutate the state, and I can use assert G to make some assertion that the state has been changed, for example. So that makes perfectly sense to use it in this case. But let's consider this second class that I call financial service, where we have a method here that helps us to compute interest given an amount and an interest rate. And we have another method that helps us to compute an increased amount when we have the amount, the base amount, and the interest rate, for example. In this case, in order to be able to execute my compute interest method or behavior, I have first the necessity to create an instance of the financial service class, this financial service object, and then I call the method on the financial service object, compute interest, and I get my interest. I do all that just to execute this function and get this result. I'm interested only in the result, but I have to go through a certain ceremony, or I can even call it a ritual, before I can get the result that I want. That's thanks to the design of object-oriented programming. This is one of the aspects that can be avoided with the use of functional programming. But before getting into these details, we need to understand also how we can pass behaviors through interfaces. one of the core aspects of object-oriented programming, and we'll see that Java took advantage of it to implement the functional programming features of Java 8, is the use of interfaces. It is recommended in Java to program on the basis of interface and not on the basis of implementation. So in this case here, we are looking at a version of the compute new amount behavior where we have the parameters, the amount, the interest rate, a bonus, but then we have a fourth parameter, and here we can see that this parameter is defined as an anonymous object that is implementing a certain interface here called new amount computable. And by going back and look at this interface, all that I have in this interface is a method called compute new amount that takes the three parameters, the amount, the interest rate, and the bonus in order to allow us to compute that new amount. So we will see how we will use the core concept of functional programming in order to implement behavior parameterization in Java. And these two, the core concept that we'll use here are lambda expressions and the functional interfaces. Starting with lambda expression, as I have showed in the other demonstration, is the fact that when we want to pass behavior through interfaces, we need to create the interface, we need to implement that interface, define a method with the signature, and then we call the method and give it an object as an instance of the class that implements that interface. But what if we could simply avoid all that stuff, avoid all this ceremony or all these rituals, and just be able just to pass the action that we want done, and not everything that's related to the design of object-oriented programming. We'll see that we can do that, and we can pass functions as values with functional programming. So coming back to my example here, my first example was with this financial service, but here I want to illustrate the fact that we'll pass the behavior using interfaces. I have a second class here called refine financial service, and in this case, the compute new amount method takes the three parameter, and then the fourth parameter is an interface, which is here defined as the amount calculator. By doing this, I am abstracting the behavior of computing the amount into a parameterized behavior that will change dynamically depending on the context of the calling. At this point in the class here, what the amount calculator is doing is not known exactly and will be known only at runtime. And so this part of the behavior is parameterized. To see some more illustration of this, we can see here different tests that are making the call by passing this parameterized behavior, the approach to compute the amount using, in the first case here, a variable that is an implementation of the interface. In this second case here, we are using it defined in an external class. That's the test amount calculator class here. That simply implement the interface. And in the third case, we are passing it directly as an anonymous implementation of the amount computable. So we have three possibilities that's still available like this in Java object-oriented programming. by running the test, of course, all the tests will succeed. It will work as expected. So what is a lambda expression? Lambda expression is simply a way to define functions as values. Instead of giving a method the result of the execution of a function, we give the method the function itself as a value that will be used to execute some behaviors later. And by doing that, we become able to parameterize that behavior, making it a parameter, so something that can vary depending on the context and the condition of the execution. So here, I'm illustrating that with 3 different type of lambda expression. In the first one, we have a consumer type of lambda expression. That means we pass it some parameters, and he uses these parameters to execute some behaviors. In this case, we have no parameters. The list of parameters is empty. It will execute system out print hello world. In the second lambda, we have 2 parameters, an amount and interest rate, and it will use the parameters to compute and return the increased amount. And in the third case, we have something that looks more like a mathematical formula. So let's see how to build. Let's see how to build these this type of lambda expressions. With further illustrations. So here I'm going to consider that I am providing to some clients a loan service. The client looks like this. I'm using Lombok to generate automatically the getters, the setters, the constructor, and so we have only the fields that are defined here. So the client has, for example, information related to the clients, how many years in service, the date of birth of the client, his level of income, whether he has a former criminal record, and extra parameters related to his social behavior, for example. In this loan class, we want to be able to select a certain amount of loan for this client depending on some specific condition. We want to be able to evaluate whether the client meets some condition that will allow us to provide him with the loan. So what we do here is we are using the strategy design pattern approach. We'll define a loan selection strategy, and this loan selection strategy will be picked up depending on some conditions. The condition that we are using here is that we are using a predicate. A predicate is a function based on a functional interface. Predicate is a functional interface in Java that takes a parameter and will give us as a return a Boolean value. Therefore, we can use it as an assessment of the client's condition. In this case, let's imagine simply that client will receive a high interest rate depending on his level of salary. That's just a simple scenario to illustrate the point. So when this predicate is satisfied, that means when the amount of the income of the client is smaller than 50,000, his case will be processed using the strategy called here new average amount strategy. And when I look at this strategy, what we are doing here is we are building a loan for which the allocated amount is an average amount of 30,000. In the case where this condition is not satisfied, at this moment we are using another strategy. And as you can see, the definition of this strategy is being done here using a lambda expression, where I say simply that to a list of empty parameter, I want to build a new loan and use it allocating an amount of 100,000 to build the new loan. Let's test this and see how it works. So in my first test here, we have a client that is defined with an income of 75,000, and in that case we can expect the result of his allocated amount to be the 100,000, because in that case what's being done is it will get the big amount strategy, and the behavior that will be processed will allow him that level of amount. By executing the method, the result is of course green. If we would, for example, change these conditions and give him a smaller income, let's say for example 25,000, the result of the execution will be here a failed test, which is what should be expected in this behavior. So this we have seen is based on predicate. We'll see that we can extend this model to a family of functions in order to parameterize a whole family of functions instead of just one function. To do that, I extend the model here to define what I call some loan conditions. We can imagine that we are not only using just one condition to assess the feasibility of allocating the amount to the client, but that there could be more conditions than just one condition. For example, that the years in service can be a criteria that could be assessed. The maximum age of the client, his income could be a separate criteria, and the criminal record also could be a separate criteria. And as you can see here in these examples, all these criteria, I define them here as lambda expressions because they are based on this interface, loan client predicate, which is extending the Java 8 predefined predicate client as a generic here. And this predicate, as I said, takes one parameter and give us a Boolean as a result. So we can use it to assess cases like we will have to obtain at the end a result that says true or false, for example. So then we can check that the tests are working as expected. For example, for a client that does not satisfy this list of criteria, the test would fail. So in this assertion, I'm asserting that for a certain given client, for example, the year in service criteria would not be fulfilled here, that the test will fail. Therefore, we are testing that is false will return true instead of is true for all conditions satisfied for client. The different method I'm using to make the test here are simply illustrating the different approaches that we could use. With all conditions satisfied for the client here, we are using a simple loop that's classical Java approach. We could think of using here functional programming approach that will be to take this list of criteria and to try to apply here a for each method on this list of criteria and say that for each client we want to execute some treatment for each client here. But this will fail simply because we're going to meet some closure issues, because in Java 8, when since we are defining some functions here, we are not directly using the value, but it will be stored as a closure. Therefore, this parameter here, the Boolean result that's defined here, should not be modified directly inside of that function that we are defining. And Java will put an error message that says that this variable should be final or should be effectively final. So this is the classic approach with a loop here. A better approach that we could use, for example, is to use functional features of Java 8 by counting the list of unsatisfied criteria. Saying, for example, here I have a count of unsatisfied criteria, and for this, I will use a filter. Java 8 allows me to stream over collections, to filter using criteria. You have also here a lambda expression, and to count the list of criteria that are failed. And I could say that the customer is eligible for the loan when no criteria has failed. That means when the count is equal to 0. And an even better approach with functional programming will be to use this case in should receive loan for the client here, and to simply stream over the collection and to apply non-match. That means we have succeeded when none of the criteria is matched, and these are the criteria of failed case, because I'm applying the negation here. It's the failed cases, and none of the failed case has matched. So that's an approach by which I can parameterize the behavior of a family of functions using lambda programming in Java, and we will see that we can further this approach. Before that, let's just notice something very interesting that is done in Java 8. When Java 8 introduced functional programming, it defines functional interfaces. So to create a functional interface strictly in Java 8, we use the annotation functional interface. But Java 8 will also consider that any interface in Java 8 that has only one method is considered also as functional interface, and which is very interesting for us, because that means we have a backward compatibility with all the interfaces that exist in the former version of Java that have just one method in the interface. For example, in the runnable interface. That's interesting because it means that we can treat the instantiation of threads as functional interfaces. So if I look again in here, I can create a simple thread from the thread class without having all the ceremony that I used to have before, but simply using lambda expressions that match the signature. The signature is a void that takes no parameter, so a list of empty parameter receive the processing that I will do to get the implementation of my thread. So let's see more cases of behaviors parameterization with lambda programming. So this will match the example that we have seen here. What we can see also is we can take advantage of the various design patterns that we have in Java that are called behavioral patterns, because the behavioral patterns allow us to inject behaviors in some certain context, and we can use them and use functional programming to parameterize these behaviors. One example I can use to illustrate this is this example with a file saving service. And for this, I'm using a file saving strategy that's defined here that simply says save file, give it the file name and the paths to use, and no other information. But in the file saving service here, we can see that we created a map, and in this map we have defined a few instances of this file saving strategy. And these instances are defined also as lambdas, using the file name and the path as parameter, and defining the behavior, whatever behavior that is. But what is important in this case, for example, is to see how we can determine the strategy to be used. In our case here, that's a simple case. We simply know that the type of file saving that we will do depend on the extension of the file. Depending on the type of file, we'll call a different algorithm to save the file. And this we can simply compute using the get extension method passed to the file. And once the strategy is found, we simply apply the method to the strategy to save the file. So this is completely generic. Even though I'm using a limited list of example, this behavior is completely parameterized and dynamic. So regarding designing families and bundles of functions, as I was saying, what is interesting for us here will be to take advantage of the design patterns that we have already in Java and Java EE. For example, the strategy pattern that we have seen on some examples functions the following way. What takes place in the strategy pattern is we have a family of functions, and this family of functions execute some processing that are very similar but are different in some subtasks or some particular cases. And so with this pattern, we execute the core process that's general to all the functions from the family, and then we parameterize the subtask that makes the difference. So that's what I'm simply explaining in this case here. The variety is on a subtask, and that's the part that we are going to parameterize. And we'll use some kind of algorithm, some kind of way to determine which strategy to execute at any time. And that is completely dynamic. And of course, as I mentioned it, in this case also we have a case, we have a design pattern that's based on a certain interface, which is the strategy interface, and it has only one method, so it's a good candidate, of course, to be used as a functional interface. Another interesting design pattern that we could use is the command design pattern, and that's a pattern that allows us, for example, to collect a list of units of work, of unit of processing that we could execute later, for example. So it's kind of similar but different from the strategy pattern, and it's based on a command interface that's also have one method, the invoke method. We have concrete command. It has user receiver object that will store the states, and from the receiver object we'll invoke the different operations that will be used to execute the processing. So some cases that we see for using it, for example, is to revert a list of actions. For example, when you use your favorite text editor and you make a bunch of actions and you realize that you made something wrong along the way, you can revert these actions. That's an example of using this design pattern. And of course, it's based on one particular interface that has only one method, so it's also a good candidate for lambda expression and functional interfaces. So let's see an illustration of this design pattern also here. In this illustration, I'm defining an interface for image operations, for processing some image. So this interface is called image operation. It has one method, that's the execute method, that takes no parameter. And from there, I will define a few instantiation of this interface, the filter image operation that implements the execute, in this case, to filter the image using an RGB image filter, for example. The resize image operation that's implemented to resize the image, and tessellate image operation. Okay, these are some image processing functionalities. And then what's interesting for me here is the image operation invoker that I will use and pass it the interface as parameter and execute the functionality. So here we are still using it in the classic approach, but we'll see using a client of this command implementation how we could use it. So this is my invoker. I instantiate my invoker in this first demo case and use it to execute the operation on a few cases. So here we instantiate the interface, but as I said, Java considers this interface as a functional interface because it has only one method, so I can also directly use it using some lambda expressions here, like in this case or in the second case. And of course, if we run the test cases that are related to that, the test cases will succeed, of course. You have also seen a receiver there. That was the image file, and that is used to handle the state. But in functional programming, we'll avoid mutating the state. We will simply return that state as a return value from each execution, and we'll handle it in another way. One interesting thing is also the decision tree. We can use it also to parameterize the behaviors. And they are very popular, for example, in machine learning, and can be used to make decision or to classify input into categories. And the way they process is after every decision, we can reach the final answer, or we can reach the end of the decision tree. So this is an example. It looks a little bit like the criteria that we used when we were defining the low-end criteria, even though it was not the full implementation of a decision tree. So this is a case also where we can completely parameterize this behavior using functional programming and lambdas with Java 8. Another thing that's interesting, before wrap up, is to simply go and see all the available functionalities that are already predefined that we can use to parameterize functionalities and behaviors with Java. There's a lot of them. They are very interesting, and they can cover almost every case. And if we fall in a case that is not covered here, we have the right to extend this interface with new interface and define our own behavior handling. So just to quickly wrap up what we have seen here, user requirements are sinking sand. They are almost changing. Object-oriented programming link data and behaviors together to make object, but that come with a certain cost of ceremony and rituals that we have to do all the time, and that are, in many cases, meaningless. We don't need to do that. The help of functional programming can come to the rescue to avoid doing that. And we have seen from the benefit of functional programming that it can help us reduce the cost, optimize the cost, and help us also keep developers happy by avoiding to always go into the merry-go-round and always face to the changing of requirements all the time on the same code. By functional programming, we can make it so that the functionalities are parameterized, that we don't need to touch the code anymore. We just need to have an impact on a parameter. And so this, as I'm saying here, it helps us to reduce the necessity of modifying the code by each fluctuation of the user requirement. So the idea here is that there will still be some user requirements, but the way it will be handled will be completely different, because we won't have to touch the code again to satisfy these new requirements. So thank you for listening, and is there any question?